Yeah, hi, hello everyone. Welcome to today's video. This is Shanmugaraj. We are continuing our discussion around the flow-based series. We are continuing our discussion on principle number 6, make value flow without interruptions. Today's topic is 8 flow accelerators. Let us jump into today's topic, the 8 flow accelerators. Each flow property, we discussed about 8 properties of a flow system in my previous video. We can refer that. Each of these 8 properties is subject to optimization, and often many steps encounter unnecessary delays, bottlenecks, and other impediments to flow. So when we say optimization, we're talking about removing the delays, removing the bottlenecks, or removing the impediments to the flow. So that's what we call that as an optimization, right? So making value flow without interruptions can best be achieved by adopting 8 flow accelerators described in this video, right? So these powerful accelerators of value are relevant to all framework levels, right? But the challenges might differ, right? So you can apply this powerful, 8 powerful accelerators for your team flow, art flow, solution train flow, and portfolio flow. I'm going to have individual videos or separate videos for each of these items. So all you need to understand that when we talk about 8 flow accelerators, we are trying to optimize 8 properties we discussed. That's all is all about it, right? So that's where making value flow without interruptions, it makes a lot of sense to us using these accelerators. The first property we discussed is work in progress. The first accelerator we're going to talk about is visualize and limit WIP, right? So overloading teams and arts with more work than can be reasonably accomplished is a common and pernicious problem, right? Too much of work in progress confuses priorities, causes frequent context switching, and increases overhead, right? It overloads people, scatters focus on immediate tasks, reduces the productivity and throughput, and increasing the wait time for new functionality, right? Like a highway at rush hour, right? There is simply no upside to having more work in a system than the system can handle it, right? So the first corrective action is to make current WIP visible to all stakeholders, right? This particular picture talks about, Kanban board, that make excessive work in progress visible. If you look at that column build, it has more excessive work, right? So this particular picture shows simple Kanban board that illustrate the total amount of WIP and the process state of each work item. This Kanban serves as an initial process diagnostic showing the current bottlenecks. Often simply visualizing the current volume of the work is the wake-up call that causes the organization to address the systemic problems of too much work and too little flow, right? So following action is balancing the amount of WP against the available development capacity. So this is done by establishing and continually adjusting WIP limits for relevant states. No new work is started when any workflow state reaches its WAP limit. So this matches the demand to capacity and increase the flow through the system, right? So limiting WIP, however, requires knowledge, discipline, and commitment. It may even seem counterintuitive to those who believe that the more work you put in the system, the more you get out, right? So this can be true up to a point, but when a system becomes overloaded, throughput decreases dramatically. Indeed, right? Indeed, there is no substitute for effectively managing WIP, right? So this is the first accelerator around work in progress. So two important things: you have to visualize it using a Kanban board, and you have to put a WIP limit to it, actually, right? Second flow accelerator is address the bottlenecks, right? Bottleneck occur whenever or wherever people or resources in the flow of value experience a demand greater than the available capacity, right? Example, a shortage of a specialized skill like data scientist, insufficient processing power for the build servers in the CI/CD pipeline, or a silicon supply shortage for building the integrated circuits of a cyber or physical system. So these are some of the examples of bottlenecks, right? So work piles up at a bottleneck and limits the effective throughput of the value, right? So as explained in this particular picture, right? So this particular wait state, there's a lot of queue here. You cannot match the demand with your capacity. So this is called bottleneck, right? So upstream processes are blocked from moving value. Downstream processes are stored and waiting. So bottlenecks cause the value stream to operate slowly and uneconomically, far below its potential capacity. So this is emphasized in the theory of constraints by Goldratt, right? Which which talks about throughput of any flow system is limited by the capacity of a dominant constraint or a bottleneck, right? By this theory, investment in optimizing the system at any other point than dominant constraint is a waste of time, right? And it will not improve the throughput of the system until otherwise you fix this bottleneck. There is no other way you can improve the throughput of the system, right? So no matter theory, bottlenecks must be addressed by adding additional skills or people or other resources at the bottleneck step, or you have to remove the queue, whatever way it is. While this is not always easy to do, right? There are reasons why the bottleneck is a bottleneck, right? So eliminating dominant bottleneck must be a primary focus, as throughput will not increase until the bottleneck is addressed. In the meantime, however, the complex workflows in a solution development provide other options, right? It's often the case that not all the work is single threaded, right? It may not always, all the thread cannot can pass through the bottleneck step. So there is often other work, different features that does not have to pass through the bottleneck, right? In this case, team can selectively pick and deliver other valuable work that increasing the value throughput while the dominant bottleneck is being addressed, right? So in addition, relentless improvement drives us to improve wherever we can do so. The knowledge workers take pride in improving the processes that are under their control. In the end, efficiency of every step matters, right? But the fact is that bottlenecks limit the throughput and negatively affect economic outcomes. So you have to effectively address the bottlenecks. That's the only way you can increase the throughput. Third important accelerator is the minimize handoffs and dependencies. Handoffs occur whenever there is a separation between knowledge, responsibility, action, and feedback. For example, dependencies happen between teams when the work of one team cannot continue until later work by another team is completed. Both result in development waste in the form of waste states in the flow of the value. So this can also lead to rework, as the knowledge transfer is likely to be imperfect, causing further delays, right? So if you look at this particular picture, right, it talks about excessive hands-offs, this all these links, right? A lot of dependency is there. You have to remove this handoff and remove. That is why you're talking about a cross-functional team, T-shaped skill sets, all those things we're talking in agile, right? To remove or reduce the hands-offs and dependencies, right? The best solution to overcome handoffs and dependencies is to create teams arts with all knowledge, resources, skills, and decision making authority to create an end to end flow of value. However, unhealthy dependencies and handoffs can still occur even when the teams and trains have all the skill to deliver end to end value. This can happen when there is a series of handoffs between agile team members, or when there are delays while waiting for decisions to be made outside the arc, right? So activities like value stream mapping, retros, and inspect and adopt problem solving workshop can help identify the root causes and potential solution, right? The solution is of overcoming handoffs and dependency is, first you have to create a team or a cross-functional team with all the knowledge, resources, and skill and decision-making authority. Second thing is, you can do processes or methods like apply that value stream mapping, retrospectives, and inspect and adopt problem solving workshops. So that is the second option. It's a reactive option, right? We can have proactive option of having a teams with a different skill set together, and reactively you can do all these root cause analysis workshops. Fourth accelerator is getting faster feedback. Learning is the foundation of improvement. and the engine that powers product development. Doing this as fast as possible speeds up the and improves the overall development process. The goal is to get positive and negative feedback into the development process as early as possible. However, we often discover that getting early feedback can be difficult for a variety of reasons. For example, lack of direct access to customers, delays in development value stream, late or infrequent integration results in discovering hidden work and defects, developing more functionality than what we needed, building wrong things or more functionality than what we needed. Fast feedback is generally achieved by applying basic PDCA, plan, do, check, act learning cycle. However, to accelerate flow further, we have found out that more needs to be done. For example, applying customer centricity and design thinking as part of the product development and engaging the customer frequently, making improvements to the continuous delivery pipeline, including build and test automation, test first practices, and continuous integration. Keeping work items on small results in faster working increment of values, right? Small batch size. Using built-in quality practices, mob work, pairing, swarming in increase team cohesion, and focus on finishing the one backlog item at a time. Upholding a solid definition of done to help the teams to work together to finish increments of value and share knowledge. Use stop the line to fix problems when they occur so that they don't pile up. So these are the six items you can implement in our company, like customer centricity, design thinking, definition of done, built-in practices. If you have agile team or if you have agile methodology, you might have most of things in place. Generally, solution builders need two types of feedback from each PDCA cycle. If you look at this picture 5, feedback about building the right thing, right? The feedback can only come from those users, customers, economic stakeholders who can measure the solution's actual value, right? So each PDCA cycle is an opportunity for this learning from each mockups, early mockups, storyboards to system demos during the development to feedback on pre-releases and deploy systems in production. Second thing is feedback about building it right. Right? Innovative systems constantly push the bounds of technology and the developer skills. So each PDCA also evaluates if the right technology is applied to optimally solve customers' problem and they meet the critical non-functional requirements that characteristic robust and effective solution. Right? So creating the mechanism and the processes to collect a wide range of data is the critical first step to promoting flow with a faster feedback, but it does not stop there. The information should be quickly analyzed, evaluated to make effective adjustments and initiate the next PDA cycle based on these learnings, right? So you need to understand how are you building a right product? Are you building the product also right? So those two feedback areas to be checked as part of your PDA cycle. Fifth flow accelerator is work in small batches. Faster feedback is one of the primary reasons for working in smaller batches. The smaller the size, the faster the teams can collect and evaluate the feedback to adjust. In addition, smaller batches reduce WAP by limiting the number of requirements, designs, code, test, and other work items moving through the system at any point. Smaller batches go through the system faster and with less variability, fostering faster learning. Moreover, since each item in the batch has some variability, large batches accumulate, more variability. The economically optimal batch size depends on holding the cost, like cost of delayed feedback, inventory decay, delayed value delivery, and so on, right? The transaction cost, right? Cost of preparing and implementing the batch, right? And this particular picture illustrates the trade-off U-curve optimization for batch size, right? So you need to consider, holding cost and the transaction cost. This red line is the holding cost. The transaction line is the green color. Then you have to consider both the cost. According to the items, number of items in a particular batch, you might find an optimum batch size for your art or for your portfolio, right? So you can use this U-curve, right? U-curve optimization method for identifying optimal batch size. To improve the economics of processing smaller batches, teams should focus on reducing the transaction cost, resulting in high throughput for a batch of a given size. Reducing batch size typically involves investment in automating the continuous delivery pipeline, including the infrastructure and automation, continuous integration, builds and regression testing, and more. Shorter iteration and PIs also help to reduce the batch size. So that is the reason I always recommend, right? In a Scrum, you can go for 2 weeks or 4 weeks, 2 to 4 weeks. We always recommend 2 weeks because to reduce the batch size. Sixth flow accelerator is reduce queue length. Reducing the length of the queue that is feeding the system is another critical way to accelerate flow. As we have all experienced, long queues are fundamentally bad. They introduce waste, delays, and information decay. In addition, Little's law, you look at this picture, Little law informs us that average wait time, right, which is W, right? The average wait time equals average queue length, which is L, divided by the average processing rate by lambda, right? So while this might sound complicated, right? So therefore, assuming any average processing rate, the longer the queue, the longer the wait, right? So what they're saying, you assume that average processing rate here, if you're having longer the length, your waiting time will be always longer, right? Average waiting time is directly proportional to the average queue length, right? So lesser the length or smaller the length, your waiting time will be less. For solution development, longer the queue of committed work, avoiding implementation, the longer wait time for new features, regardless of the team's efficiency. For example, suppose an art has an average flow velocity of 10 features per quarter and a committed backlog of 30, right? In that case, customer may have to wait as long as 3 quarters before any new features can start developing it. So this example explains why queues are fundamentally bad and can significantly delay the ability to respond to the customer needs. So reducing the queue length decreases delays, reduces waste, increases flow, and improves predictability. So it is a requisite for a faster service and a more consistent flow of value, right? Seventh accelerator is optimize time in the zone, right? Let us understand what is time in the zone. Being in the zone is an engaged mental state of extreme focus on activity where the work feels effortless and time passes quickly, right? People and teams in the zone demonstrate higher creativity, productivity, happiness, and fulfillment. Getting into this mental state requires, uninterrupted focus time, autonomy, confidence, and connectedness to others to engender self-actualization and instructing motivation. Right? If you look at this picture, if there is an 8 hours of full day, all these dark chunks, right, they call that as a time in zone, right? We are assuming that 2.5 hours of time in zone, we have 8 hours in a full day. That means the 30% of the work day is spent in the zone, right? 30% of the time that particular team member or team is spending uninterrupted, highly creative, time, and highly productive, and most of the work are done in this period of time. You might have a lot of things to do: emails, team sync, peer support, right, task switching, lunch. You might have number of activities to that. So every art team need to figure out the time and zone for each individual, and they have to work, right? So often the time and zone is often a fraction of total work day, right? So that a team need to understand, a team need to figure out, an individual has to figure out how to optimize the time and zone. This is going to be the flow accelerator. So contrast to this, right, to the conditions in a typical work environment where work occurs in a functional silos, in a batch queue handoff system, right? So these frequent interruptions, right, emergency requests, ad hoc status reports, constant communication alerts, and so on are the norm, and excessive WIP drives frequent task switching. So you need to avoid that typical work environment, like an emergency request, ad hoc status reports, or a batch queue handoff system. having a functional silos in the system, right? So all those things you can avoid. So try to optimize the time and zone. Eighth and final flow accelerator is remediate legacy policies and practices. During or after a lean agile transformation, enterprises must constantly look out for legacy policies and practices that inhibit flow, right? Many of these practices become part of the culture or described as we have always done this in this way only, right? So even when they are no longer fit for the purpose. So examples are many, right? So like continued reliance on phase gate milestones and iron triangle of fixed scope, resources and time, right? So in reality, all three components become fixed instead of trade-offs among constraints. Absolute or unnecessary change control boards, including extraneous oversight and reporting, waterfall-based quality management system for regulations and compliance, absolute tech standards, design specifications, audit practices, in environments where they are not mandatory or required for quality, continuation of timesheet reporting in addition to agile lifecycle management tooling requiring a double recording of time, traditional HR performance reviews and compensation policies that cause unhealthy competition. Agile is adopted only by the team. The mindset of the management and portfolio governance remains unchanged. So these are the some of the olden way of working, legacy policies and practices. We have to get rid of these kind of things, try to remediate, have a different culture, new policies for your system. So this particular picture talks about the mass of legacy policies and practices. They're given some more examples here, right? So extraneous meetings, extra reporting, timesheet reporting, legacy change control board, waterfall quality management system, waterfall mindset, iron triangle, stage gate milestones, legacy compensation, absolute standards, right? This is not an exhaustive list, but while many of these patterns may well have solved problems in the past, they now create a new problems that become ongoing impediments to the flow. So they must be proactively or reactively discovered, eliminated, modified, and mitigated. With that, here the conclusion of this particular video. Hope you guys got a fair idea on 8 flow accelerators, right? How do I optimize 8 properties of a flow that is called flow accelerators? So you need to look at all these flow accelerators when you build your value stream, when you look at the flow of the value stream, so you can optimize all these areas. Hope you guys like this video. If you like this video, please share it across and spread it across with your friends and other people, our colleagues, so that it reaches many people, so that many people get benefit out of it. And I would like to understand how the flow accelerators are being applied in your company, in your system. I would like to listen from that so that I make my comments. I also learn from that. Okay, so that I'm signing off from this video. Okay, bye bye.